So in this tutorial, we're going to cover some practical application of pandas and applying it to a real data set. So the first thing we're going to do is install our packages. So we're going to import pandas as PD, import Seaborn as SNS. And we're just importing Seaborn because that's where we're going to get our data from, just so you guys can follow along nice and easily. So once our packages are loaded in, we're going to type out this line right here. Now, what we're doing is we're pulling in our data set from Seaborn using sns.load_dataset, and it's the Titanic data set. And we're passing it to the DataFrame function just so we truly work with a data frame. You don't necessarily need this, but for our tutorial, we're going to use it. Now, in previous videos, I've covered these functions here. This is another way you could load in data, and it works just the same. Oh, second. And I just have these highlighted because we're not going to actually use them, but there are other ways to load in data. Now, what we can do here is we could see our data that we loaded in. It's going to be 891 rows, 15 columns. Now, the first function we're going to run here is df.count. Now, what this does is it counts all of our variables that we just looked at. So we saw it was 891 rows by 15 columns. And we can see this isn't missing any values. We have some missing values here, a few missing values here and there, a lot of missing values here, etc. Now, to check this from the other angle of missing values, we could do df.isnull and then pass the sum function at the end. And we can sum up all of the null values. We can see we have 177 missing age variables and 688 here, 2 here. Now, a more efficient way to view your data frames, we could pass through the head function, and this allows us to just see the top of our data. And if we wanted to see the end of it, we could actually just do the other half. And what's nice about this function is say we have maybe 100 variables, we could just look at maybe the first 30 by just passing through 30 here, starting from 0. Same thing here. If we want to see the last 10, for example, we could do the same here. Now, another thing that's nice about Pandas data frames is the indexing ability. So this is how we could index, and this will simply just give us one column. And we could pass through other functions here. So something like .min, we could do .max, .mean, etc. And that takes it for the entire column. We could change this to any numeric variable like fair and get the same result. And we could store this in something, so say like average underscore fair equals, and then we could use this variable later if we would like. Another cool feature is that we could make something like a cumulative sum. Oh, so perfect. Our AI detected that and wrote the code for us. And now if we run this, see after we ran that, we have this cumulative fair column, and it runs all the way down until we have our end sum. And just in one line of code, we were able to add an entire extra column. Now, something I should have shared before is the df.describe function. But now that we have this in here, it might even be more useful. So here we can get quartiles, count, mean, standard deviation, minimum, etc. All the functions I was doing up here, just in one simple function. Now, to add on the idea of indexing as we did earlier, what we can do here is we're going to do sub1. We're going to do 2 brackets to index, and we're going to go by who as one of the columns, and we're going to do alive as the other column. We're going to run that, and I'll just show you what that will do real quick. And you can see it just takes 2 of the columns from the previous df data frame and just keeps it in sub1 now, which is our new data frame. So now what we're going to do is we're going to experiment with something called iloc. So we're going to do sub1 equals df.iloc. And we're going to start from 0. So we're going to not even type anything. And we're going to end at 400 rows. Now, once we run that, we could view what we did by just simply typing in sub1. And we could see it just gives us up to row 400. Technically 401 starting at 0. Now for sub2, we're going to do the same thing, and let's just start at 700, for example. And let's change that, run that, and this is what we're left with. So what we do now, if we want to combine these back together, is we can do pd.concat, and it already knows what we want to do, sub one, sub two. And now you can see it combined both the data frames for us. Now, some practical application is maybe you want to cut out just that middle part of the data. Who knows, maybe it's dates, times, you want to get rid of a month if it was a time series data, etc. Now, in our next line, we're going to do some filtering and slicing. We're going to start off with df. We're going to write df again at another column. And let's do age, for example. Now, let's do only adults, so people who are greater than 18. Now, what this is doing is we're selecting a data frame, indexing by df age, and we're setting it greater than 18. So this is only going to leave us with people aged 18 and older, essentially. And we could see here just off the first 25, it did exactly that. We could once again change this to anything we want, say 48, and it'll leave us with people who are over the age of 48. Now, something else we could do, if we want to do it with strings, it's the same idea. So we can change this to class, change this to a double equal sign, and then just set our string equal to, say, for class, we could do first. Now you can see it left us only people who are in the first class. Another powerful tool that I personally use a lot as well is group by. So for this, I'm going to create a subset with the same code we did earlier. So who, we're going to do alive, age, and let's also do fair, for example. So now our subset variable only contains those 4 columns. Now with that, I'm going to use the group by function, and let's see if it detects it, what we're trying to do. Who, alive, and mean, perfect. Yeah. And just like that, it grouped by child, man, woman, which was who, alive, yes and no, and then our 2 numeric variables of age and fair. Now, some other quick functions we could utilize are something like df.drop, and let's do embark underscore town, and let's do axis equals 1 to make sure we drop the column. Now, you can see we no longer have that column. We could do this with any column we would like. For example, if we want to get rid of gender, we could do that. If we want to get rid of age, we could do that as well. And you can see it brings back our other column. As long as we're not saving it into a variable, it won't manipulate your initial data frame. Now, say, for example, we wanted to know how many unique towns there were. We could simply run the pd_unique function, and instead of class, let's replace this with embark underscore town. And the unique function only returns unique variables within a singular column. So we have Southampton, Cherbourg, I believe that is, and Queenstown. And we have a missing variable. Now, what we could also do is we could do df underscore drop duplicates, and it already knew exactly what I wanted to do. Now you can see, for example, it only gave us our unique values, so 1 from each town. We could change this to anything we would like as well. So say we wanted to do age and only get unique ages. We can see that each of these is unique by itself and none of them are repeating. Give another example with just gender, and now I can see we have 2 variables. Now another really useful function is df.sort values, and you can see it already knew exactly what we wanted to do. So we can run this, and what this is going to do is sort the highest fares to the top and the cheapest to the bottom. We could switch this around if we would like by just replacing this false with true. And now we could see it's the other way around. And one of the last functions we're going to be using is indexing with is_in. We're going to use embark town again. And we're going to use the is_in function right here. And we're going to run this. Now you can see it's only leaving us with data that has Southampton and Queenstown. And it got rid of anything that is not such. We could do this with some other variable, like say class, and we change it to only, let's say first, and second. So now it only left us with people who are first and second class. Lastly, what I'll do here is I'll actually set this to just A, run that, so now it's stored. And what we can do here, we could do a.to_CSV, and we'll call it data.csv. And now if I come over here, you can see this data is stored here, and I can go and download this and use it on my own personal device right here. And we now have it in its own frame. We could do the same thing here with Excel to Excel, and just simply change this to XLSX. Close that, reopen it, and now it's right here. So this was just to cover some basic pandas functions. Now this is far, far, far from all the pandas functions, but just some that you might find useful, as there's some I use all the time myself.